Our next presentation is one along a theme, which is how do we do some critical functionality in an IP world that has just been things that we haven't even thought about for years as we've worked in SDI facilities. And one of those things is event and tally. You might know them as GPIs or some other function, but basically, if I push a button and I want to light the tally light on a camera, it's very easy for me to do that with wires or some sort of older computer protocol. But if I'm going to do that in an agreed common way across the industry in an IP environment based on 2110, how am I going to do that? And how do I do that in a way that scales to potentially thousands, hundreds of thousands of events that might be occurring in a large broadcast facility? So to talk about today is David Atkins. David, come on up.
Right, so, yep, David Atkins, Suitcase TV's CTO. So, get the, why do I need event and tally? So, as Brad has said, GPIs, that's the obvious thing, but there are so many signals now that in today's world we rely on in our broadcast networks. And the tally lights there, but the weather, the lighting, there are many things that we could put over an IP protocol, and we don't really want to have many different protocols for this. So at the moment, ANWR MMOS ISO 7 is a work in progress. It's been published on GitHub, and the goal is to try and get that approved sometime in October. I think Brad would like me to say sooner than that, but we'll get there. MQTT is the primary method of pushing this around, and I'll cover why MQTT at the moment. Sorry, why MQTT later, but the possibility exists to handle other transports, and we think of that layer as a transport. And then finally, I'm going to show you where some of the demos are at IBC of this, because they're not in this room, and the next steps we're getting to. So, GPIs, contact closures, relays, lamps. We always think of them as being quite simple, but actually we can build quite complex systems from this. And I'm always being dragged back to the simple side of this by the people who know better, but we need to find a way of hooking together that lot, but with the IP and the software world. And the software world, as we know, can be quite complex. It's real time. When I press this button, I want this to come on. Now that's true in an analog GPI world, but it might not be true when we have delays that are going through the system. I need to be able to put some timing around this to make sure that I know where I am. And I'm afraid PTP will occur later in this conversation. So I don't expect you to read this, but this is how ANWR works. We have to put together a proposal. It has to go to the board and make sure there's a business case for it. So amongst the things that we put in there is things like, as a vendor, I need a simple protocol to make this work. I need systems out of pure IP. I don't want to have to go back to GPIs if I don't need to, but somebody can have an opportunity to make a IP to relay conversation, or indeed an IP to a Q-like conversation. So I won't go through this in detail, but that's the shape of it. I think all the presentations will be online at some point if you need the URLs. So, IP workflows. Everything here has to be around IP, and our underlying protocols need to be IP. I don't think that's anything other than a given. Timing. So, timing is critical in these things. If we are attempting to time something in a remote facility, we want it to happen at the same time. We don't know when our message is going to arrive, and therefore we don't know when to send it. We just need to be able to send it in advance of that. We know that networks have jitter. we want an open specification. So everything we do is got to be around open specifications and scalable. If it's not scalable, then we're kind of wasting our time, because for a simple system, that's fine, but we need to be able to scale to hundreds of thousands of connections and hundreds of thousands of flows. We've based the work we're doing on the same as video and audio. So we have an event sender, and that sender just sends these events through to the network. And the tally is a generic term here, so this tally could be a relay, it could be a light, it could be a much more sophisticated device. One of the things that, as Suitcase TV, we kind of worked out this was necessary. We started implementing it, and we consulted with our industrial partners about how we should go about this. And I think that over the last couple of years, we've been able to refine what we're doing until we can make an open source contribution to the AMWA project to make this happen. And I think I encourage anybody who has something that they feel is important to approach AMWA and contribute it to. It might get changed, a bit like ours did, but it is a firm basis for getting out there. We started off with RTP, stroke UDP, and multicast. We've actually ended up with a TCP connectivity for a lot of reasons that once we looked at the scalability, it was obvious that multicast doesn't really scale to an enterprise level organization. So in what we're doing here, we need to be able to work across VLANs and IP networks. So briefly, the relationship with ISO 4 is that, and again, these aren't great, but we're registering senders of events, and each sender of an event is registered so we can find them on ISO 4 discovery servers. The connection management, I've Atos screenshots here, so as you can probably see. So again, we're using the ISO 5 connectivity model because it's there, and we would be very foolish not to. What it means is that we can establish connections between pieces of kit, and then we can park those connections and re-establish them somewhere else. So if you want the flexibility of one control room running multiple studios, you can have that. So we're not having to go back into the patch panel and replug a GPI if that's what you needed to do. So MQTT. MQTT is something that's been around for quite a while. Message queuing, I don't know, forgotten the T. You just refer to it as T, and it doesn't say P on the end. It is widely used across industry. And again, as various people I think have been mentioning through the day, we need to look outside of our industry to find stuff that works and is a standard and is widely accepted and runs on a variety of platforms. So this is utilized in all of these spheres, and yeah, broadcast isn't there yet, but we'll get it there. There we go. Message queuing telemetry transport. So it's a bit of a mouthful. It's a publish subscribe model. And what does that mean? Well, when you want to know if you have a broker and your broker has multiple subscriptions for different topics, you can also wildcard this, etc. But in practice, in most of the time, you're going to be listening to specific topics. You're not drowning in data you don't need. It's asynchronous, so that there is no handshaking. Widely adopted, low latency. Because it's got a TCP session that's always open, the message can get you. You haven't got to keep requesting for status on the message. It's TCP. We can guarantee delivery within the confines of TCP and the fact that that has to be there. A simple code base. There are many open source implementations of this on multiple platforms. So you can do it on your phone, you can do it on a PC, or you can run it on a small ARM 32-bit CPU in a free RTOS. So it's widely available and is used to make temperature sensors. I've seen it in parking sensors in car parks. IoT is very widely based around this, amongst other things. It's web browser compatible, so the brokers have a WebSocket implementation, and they can make a web client, your browser, actually work. Now, what that means is, as a broadcaster, you can develop your own control protocols, but you're using a common standard. And that's quite important for our customers who can't wait for us to implement something. Or if it's something simple like implementing a doorbell, then they can do that. So it's very simple to do that. You have it on your phone. You know, Facebook Messenger and WhatsApp, their core backend is MQTT. So this is very widely accepted and highly scalable. So I've got, so highly scalable. There are people who've tested this to 1 million or more connections at any one time. And those servers are clustered, but 100,000 connections is possible on a relatively lightweight PC. So the message is, it's so simple. I did this and went, I don't quite believe this. So we have an identity. It's very MMOS based. Source ID, that's a GUID, and a GUID is a globally unique identifier. We know that nobody else is going to have that identifier for our source. It's ours for all time. We have an event type. Now, an event type here could be a number, and we support the basic JSON type, so we've got number, string, Boolean, and then complex. We haven't really worked with complex yet, and we haven't defined that, but we know that we can get to that. But a tally could be a simple Boolean value, or it could be an enumerated type which has got some strings associated with it. So it's a very simple way to go. At its simplest in timing, we can do a creation timestamp. So if I've got a doorbell and I want to know when it was pressed, this represents the PTP time that it was pressed. There are some other options in here for expressing when you would like the action to take place, but I won't go into the detail of that, because that's what the GitHub is for at this point in time. And then finally, we have a payload. Because we've got a number, that's the value. If it's a complex type, then it will be a JSON class or object that would be expressed there. So it's a very, very simple protocol running over a well-established mechanism. So demos at IBC. Pebble Beach have got a demo set up, which I still haven't seen, if I'm really honest, but there you go. But the aim here is that they've got a process which is being controlled by ISO 7 on their platform. They're being partnered by BNCS with Atos. And again, you'll see those screenshots in a bit more detail if you go visit them. Suitcase TV, we've done a similar thing, but we've got a Sony Visca camera, which we've bridged through our gateway so that ISO 7 from Atos comes through our ISO 7 gateway, and then we speak Visca to the camera, and we can position the camera. Now, it's very simple, but actually that's what this is targeted at, and that's why we're at the moment focusing on the simple requirements. But I think you'll be able to see where you could go with this once you've established this. And I think for me, this is about how do we move forward, but we have to start with a simple and well understood basis. I'm very conscious that I seem to be rushing through this, but there you go. So next steps for us. One of those is we have to get the draft specification out there. We encourage anybody to go and read it on GitHub, and then you can comment through that. We'll look at those and see where we go. We want to encourage vendors and customers. So I'm talking to customers all the time about this, because our larger customers have got their own software development internally. They don't really know where the open standards are going to be, and this is going to be one of those open specifications that's going to make life easier for you. So some of those customers are even using MQTT at the moment to build their service buses. So they understand that bit. We just need to extend that. We need to look at how we can extend this if it's appropriate. Now, that might be purely by defining some device models. It might be by having a glossary. It might be by having a registry that's globally available of device types and complex types. But we need input to make that happen. So we've been very quick to get to the initial step, but what we need to do is to get more input from the industry and the customer base. I personally think the customers are actually going to be more important here than industry, because industry is still worrying about video and audio over IP and not workflow. And as a vendor of workflow that's over IP, this is really, really important. So I think I have managed to race through to the end. So I guess any questions would be the next.
Absolutely. Do we have any questions about the approach that we're taking to event and tally? No? Oh, yep. Love it.
Could you kind of alluded to the fact that with the creation timestamp, that's obviously like the doorbell press, that's when it was pressed. But if that triggers a sequence of multiple events, is there a propagation of that original button press time that's held in the messages that subsequently get?
Yeah, so creation time is the creation of the message. But we have an origin time, which then becomes the subsequent actions that would ripple on from that. So that doorbell may actually be 17 events. One of those might be play a clip on a server. One of them, we're not worrying about what the doorbell does, but we are worrying about when it was pressed. The origin time tells us when the doorbell was pressed, and then there is an action time which tells us when the action should take place. So if I need to schedule it 300 milliseconds in the future, then I can also send an event that would do that. Or if actually I wanted to send it in the past because I know I'm playing catch up. We don't intend the activation time to be a scheduling thing, but it's to allow us for adjusting the delay in the IP solutions. And we know that there's going to be delay here. So we kind of want to schedule that in the future.
And I don't know enough about MQTT, but what's if multiple things are listening to the same trigger, what's the kind of spread of the likely reception time? How low is the latency, and so you get it at the same time, or
it depends on your server. So a good server will be multi-threaded, and the reason why we've got timestamps in here is to make sure that we don't have to have too much sensitivity around that somewhere. Not sure what's happening there. So the goal is to have the timestamp be the time that you wish to have it, and therefore you can send things out. So you might be reacting to the doorbell, but the control system, which we're not worrying about how this works, can then use a new activation time which it can schedule across multiple devices. So that might be top of frame, because when I press that doorbell, that's not frame synced under any condition. So this allows us to then bring it back into line with the black and burst. Sorry, yeah, I know. The black and burst version in IP, because ultimately we're making content, right? And all of this is just noise. The content creators want to be able to use their systems, but we have to be able to look at how this works. And if I wanted an IP prompter, I need to think about how I'd light those red lights on that prompter. And for me, that's kind of, let's solve that problem before they find out they have it. So,
other questions?
Hi, David. What kind of broadcast products, what classes of product and device can this be applied to?
Any of them? I think where we'll see this to start with is going to be devices that have simple functionality. So, tally, event. I'd like to think cameras. I know there's a possibility of somebody with a wireless Q light system who's interested in doing this. So, all of those are possibilities. I think that we'll see this working its way into triggering audio. If I want an audio play, well, hang about. This provides me with a really simple way of using PTP to synchronize the playback. Or maybe I need to channel map my audio, but in the future. So there is, within AMWA, there is discussion around those use cases. So I think that, in principle, anything, but I think that we'll see a focus around live production systems initially. So.
But there is also a scope point here, which is that what goes on, for example, in a router control system is actually very, very complex, especially if tie lines are used or if there's other, below the screen monitor displays or so on. And we're specifically not in the AMWA about the business of building control system products, right? So this does have a scope cutoff where at some point our assumption in the AMWA is that the industry will innovate and create those kinds of control systems. But on the other hand, if I push the doorbell and the bell should go ding somewhere, we need a very simple, straightforward, easy to understand way to do those sorts of things. Because it's, speaking personally, as with my background in Turner Broadcasting, we had those kinds of applications everywhere. And they were not router control systems. They were not very complex things. They were things that I needed to be just very simple, where in my facility, I could add some little thing that could listen for the doorbell and turn on the coffee pot or, that whatever, process-wise. Just a very simple way to take care of little problems where I didn't need to go bother a vendor to implement those sorts of things. And so I think that's one point. You might be listening to this and saying, oh, well, this is really simple. If you are,
yes,
job done. That's great.
A table lamp can have an on-off control, and it can have a brightness. It might have a color of its RGB, but it sounds painfully simple, but actually to make that work with GPIs, well, that would be a challenge. But to make it work across multiple vendors, well, all we have to do is have a way of communicating, and then we can map it onto it, and we can discover what capabilities that device has by asking the ISO 4 registry. And that, for me, is the point, that people who make control systems can use this to discover the capabilities of all the interface points in and out of the system.
I'm a huge fan of AES 70, and there is very little adoption of AES 70, and there's very big debate about RESTful APIs and other things. And as we're creating devices that are Internet of Things devices, why does the VSF or AMWA take the approach of not leveraging Internet of Things technology such as MyQTTP, the time protocols, or any of those types of protocols? MyQTT, the Internet of Things telemetry protocols.
So,
you did. Sorry, it's all there is.
So
I only showed up at the last 5 minutes. I'm not going to lie.
But let me take that.
Okay, so sorry. Then let me extend this. So we have SNMP and all of those things in that class structure. Are there going to be similarities between your JSON structures and some of the SNMP object variables that we're dealing with?
I think at the moment we're trying to deal with a very, very simple a simple set of objects, and that's intentional because we need to get something out there. The reason why we can support complex objects is precisely that. That gives other vendors and other suppliers and other customers an opportunity to go, this would be brilliant if we can do that.
Absolutely. Well, I'm an audio company, and there's on, more on, and off. And most of the parameters can be summarized with that. And if we can agree with on, more on, and off, I would be extremely happy. So Thank you for your efforts.
I I'll have a chat with you afterwards, but there is if you're a very keen AES-70 adopter, then that's absolutely fine. I'd love to talk to you about how we can make that work. So, we'll see where we go, but unfortunately, we have to deal with where we are now, and to be honest, we don't have a way of turning on or ringing a doorbell over IP, and that's a problem for the industry right now. So we can scale that, and maybe we can get there. So,
all right. Thank you. And to your point, I think that one of the things, I'm the executive director of the AMWA, and so one of the things that I've been working quite hard on is understanding how we can make a very solid bridge between the professional audio domain, which generally has its own user requirements, and the broadcast playout and broadcast origination or post-production environments, which have their own use cases. And so while I don't know necessarily, it's unlikely that we would adopt all of AES 70 or all of AES 67 in our environment. Speaking back to my Turner days, I was the head of engineering and operations worldwide for Turner Broadcasting in the entertainment division. So if you watch Cartoon Network or TNT or any of that stuff, those people work for me. And we had very large audio post-production facilities where the bread and butter was all of that 196 input consoles or more and live sports production and all of that, right? But then the broadcast environment is different, but it was vital to my business interests that we were absolutely joined at the hip between the professional kind of media playout and production environment and the audio post. So it's a critical part of my thinking and the AMWA board's architectural strategic thinking to figure out how to interface very well with what's going on in that environment. And we want to keep it simple, like you said, on, more on, off, MQTT. There's some environments in the broadcast world where we don't want to use MQTT because, as you alluded to, there are some race conditions, there are some huge deployment conditions where really in the broadcast environment we want to absolutely positively guaranteed know that everybody's talking to everybody at all at the same time. And in those conditions, this proposal supports other protocols as well, where we have the appropriate layers of abstraction, but then you can substitute out MQTT for something else. But hey, you know, if the simple MQTT thing where I can go give a development engineer a Raspberry Pi and say, just say, you know, do apt install MQTT.broker, whatever, and then, you know, short these two pins together and make the light. I mean, that's actually hugely powerful if, as an industry, we can adopt that rather than, okay, first download all these C libraries, then go out and get this and compile all this stuff. And that's just a road to nowhere, right?
As a business, we thought multicast is definitely the way to go. But actually, it's not as easy as just one network, and we need to be able to bridge across that. We might still need to go back to multicast and UDP. I'm not ruling it out, and there are other options for that transport. But the key bit is use the JSON and ISO 7, and then the transport takes care of it for you.
Okay, thank you.
Hi, just can you go back to the object structure?
That one.
Can you elaborate a little bit more on the source ID, which I understand is the doorbell, ID of the doorbell?
Yep.
Which is essentially a one-by-one matrix.
So
what if you have, I want to know if camera 5 is on preview bus and or on the aux bus?
So
would you combine those, or would each cross point be its unique source ID?
So what we're trying to do here is we're trying to divorce the control interpretation of this from the message itself. So that's the first thing I'd say is we don't want to tell you how to control the system. That's not what we're trying to do. The source ID is just the number of the doorbell, and it's guaranteed to be unique throughout the world. And once I have that and a registry, then I can find that doorbell if I can see it in the registry, and I can start to get messages from it. So it really almost feels too simple what we're trying to do here, but if we don't do that, we then can't build the more complex systems on it. And we as an organisation, I think we should not be trying to tell you how to build control systems.
So, okay, go back to the doorbell. So there's a big apartment building, and there's 4 doorbells.
Yep.
Does each doorbell have its own?
It has its own source ID.
So in terms of a video switcher, each cross point will be its own source ID.
Conceivably, if the cross point tallies, then that's what you do. But that's your choice as a manufacturer.
And getting all the source IDs, that would be covered in ISO 4.
That's correct. Yeah. He's been listening. Hooray.
Right. Very good. So the whole point of this is that this scales to Twitter. Millions of interactions per millisecond. So how you build the information that you collect from the registry based on these and the source IDs and how you present that to a user or what products you build out of that, it's at this level, it's agnostic, but we want to give you that information available to you in a way that's very common and that the internet is built so that then you can hire people who are developed for that and they can very easily program up how a whole router or something else would work. So it's really a key point that you said, David, that we're not telling the industry how to use this information. It's just, this is a doorbell, this is his ID. If you get something that represents that it's this ID and it says it has this state, it is. Now that may come from 4 different places, but if you get this ID that you can trust, that's a guarantee across the network, right? This ID is ubiquitous and immutable, but if somebody shows up with that ID and it's got a state, use it.
You could have a rotary knob for your doorbell for those 14 flats, including a 15th position where it's not likely there's no one there. But that's your choice again. We're not telling you how to build systems. We're just telling you how to communicate the information at a very, very low level. So
that's it. Oh, yeah.
So if you don't tell people how to make the system, how would you tell other people to listen to the system? I mean, that's where you're making a standard for, right?
So 04 allows us to discover all of the senders in the system and all of the receivers in the system. And 05 allows us to connect them. So we can connect line in 5 to a tally light, and that connection is made. If you want to offer a security model for that, that's what happens in your 05 server. Okay. But again, we're not telling you to do that. We're not telling you not to do that. Yeah?
I was just going to say, to equate it back to the GPI side of things, as broadcast manufacturers, you might choose to put, 16 GPIs on the back of your Vision Mix so that you can program in the software to do different things, whether for input or output. And this is where kind of I see this working is the generic level of triggers and events based on what it's hearing. It's make a standard, really simple protocol, hope that broadcast manufacturers add it to their equipment so that the people who can't afford to engage the vendors to do custom integration can do it all themselves by linking it through these kind of protocols.
Yeah.
Correct. And to that point, it might be extremely important for me to know in some workflow that an ingest has ended. I might need to send an email to somebody in our traffic department who handles the actual scheduling of that into the scheduling system for playout. I could go to a vendor and pay for development for that, but if I can make a Raspberry Pi subscribe to the event that has to do with when the ingests are finished, and it picks up that ID and recognizes it and sends an email to somebody in my traffic department, I've added a lot of business value to my overall system, right? And so this gives a way that vendors could implement some sort of a messaging protocol that would allow not just inter-vendor integration, but it would allow the users to take something very simple and add value to themselves that would be out of the scope of the requirements that you would give to a vendor. So it's really powerful.
And hopefully, finally. So
it better be. Rob's in the wings, he's tapping his foot.
So the last thing that this does is it allows you to have a distribution amplifier for your GPIs.
Absolutely.
You can have one device or 100 or 1,000 subscribe to the same message. And that, you can have...
Or a million.
Yeah, you could...
Literally,
yeah.
with the proper infrastructure, literally a million.
Yeah,
or
so you
more.
could have an LED and an email being sent, and those could be operated by different systems. And the studio status light can be attached to the same thing. So, right.
Okay. Thank you very much. If you're interested in joining this work or finding out more, contact David. David, thank you so much.